Okay, today we're going to be looking at inverse proportion. So let's have a look to see what this is. Imagine you have some rectangles. We've got a nice long thin one, we've got a bit of a fatter one, and we've got more square one. Now each of these rectangles has an area of 20 centimetres square, so that's 20, and that's 20, but we can see that they're all different shapes. This one has a length of 20 and a height of 1, this has a length of 10 and a height of 2, and as you can see in the middle in proportion, this is 5 and this is 4. Now what we can see that the dimension size goes down as 1 increases. So look at this one, this is 5 and 4. But as the 4 goes down to 2, the length that was 5 now goes up to 10. And as the height here goes down to 1, the length goes to 20. We say that the product of these two, so if x and y are the length and breadth, they equal 20. We can say that y is 20 over x, or y is inversely proportional to x. So we could write that as y, and this is the symbol for proportionality, is inversely proportional to x. The formula for that would be y, in a general sense, would be y is equal to k, some constant that we don't know, over x. So this is for inverse proportionality. There we go. So let's look at a quick example of this in practice. So we have two quantities, x and y, such as y is inversely proportional to x when x equals 20 and y equals 6. Find the formula for x and y. What is y when x equals 40, and find x when y equals 2. So let's look at that to begin with. So firstly the formula. So y is inversely proportional to x. So y equals k over x. So we know that when y is 6 when x is 20, so we can find out k is going to be 6 times 20, so k is going to be 120. So y equals 120 over x. So what's y when x is 40? So y would equal 120 over 40, which would be 3, and likewise if y is 2, we can put 2 equals 120 over x. X is going to be 120 over 2, rearranging the formula, which is going to be 60. So it's quite not too complicated. Let's think of this problem. A scientist has squirted a droplet of oil on the surface of a container of water. The oil has formed a circular patch and is slowly expanding. The thickness of the circular patch of oil is inversely proportional to the square. Of the radius r. When the patch is radius 3 centimeters, the thickness, which we're going to call d, is 60 microns. Now a micron, let's write that up here. A micron, just for your knowledge, is 1 micron is 1 times 10 to the minus 6 meters. So it's quite small. It's very small. Write a formula connecting d and r. Now we're just going to keep the d as microns and we're going to keep r as centimeters. So k over r squared. So the thickness of the droplet is some constant k over r squared. And so we want, if the radius is 3 and d is 60 microns, so 60 over k over 3 squared. K is going to be 60 times 9, which is going to be 540 now. So the formula will be is equal to 540 over r squared. So let's think of b. Find the thickness of a patch of r is 6 centimeters. So the thickness will be d 540 over 6 squared. Do the maths. You'll find it is 15 microns. And finally, C. The scientist hopes to end up with a patch exactly 1 micron thick. What must the radius be? So C equals 540. 1 is 540 over r squared. So the radius must be square root of 540 rearranging the formula, and we don't want r squared, we want the actual radius. I'll just do it a bit more. And that will be 23.2 centimeters to 3 significant figures. So yeah, I hope that helps.